Okay, so this is the review for the chapter 10 in geometry. So it says that assume any lines that appear tangent are a tangent. So it looks like this line right here is a tangent line. What happens with a tangent line is that if it intersects a circle just at one spot, and it meets the circle at 90 degrees if you draw a radius to it. So here's a radius, so it forms a 90-degree angle right there. So what we have here is a triangle. It gets created and we need to solve for that angle x. So we'll go ahead, and that's 90 degrees. We'll take 90 and 58, add it together. So that's 148. We'll take that 148 and subtract it from 180 degrees because all the angles in a triangle will add up to 180. So that's 32 degrees. For number 2, kind of the same situation, but I have two tangent lines. Here's a tangent line, here's another tangent line. What happens with that, again, is what gets created are right angles here and here. But our shape is a little different this time. It's a four-sided shape. And four-sided shapes add up to 360 degrees. So I'll take the 90 from there, I'll take this other 90, and I'll take the 130 and add them together. So 90 plus 90 plus 130 is 310. But this time I'll take the 310 and subtract it from 360 because this is a four-sided shape, a quadrilateral. And quadrilaterals add up to 360. So making that angle x 50 degrees. So number 3, still dealing with tangents. So the line AB is tangent to that circle. So this is the tangent line. So that means this line, or this angle right here, angle B, is a right angle 90 degrees. So to solve for x, what happens, or what got formed, is a right triangle. So to solve for x, we're going to use Pythagorean theorem. We're going to use a squared plus b squared equals c squared. I'm going to call a my x, b 8, and my c is 10. Make sure you make sure that c is always the hypotenuse, the length across from the right angle. So this is x squared, and 64 equals 100. I'll subtract 64 from both sides. I'll get x squared equals 36. And I'll square root, and I'll get that x is equal to 6. So the radius on that circle is just 6. Number 4, I'm supposed to find the perimeter of the triangle circumscribed about the circle. So there's a triangle outside the circle. Each of these line segments touch the circle at just one spot, forming tangent lines. So this line segment, that's 4, is also tangent, should be equal to this line segment. So this should also be 4 because tangent lines that meet outside the circle are congruent. So these parts should be equal. So if this is 3, then that's 3 also. And since this is 5, this is also 5. So to find the perimeter of the triangle, I just add up all those pieces together. So I can do 4 plus 4 plus 3 plus 3 plus 5 plus 5. And all that adds up to 24 centimeters. Okay. So number 5 is dealing with central angles. So central angles are angles that go through the center of the circle, and they just kind of form things that look like pizza slices. So I'm supposed to find the measure of angle BAF. That's this angle right here. Well, it might be beneficial for me to find just all these parts first, okay? And then I'll find the angles and the arcs. So clearly this is 90 degrees. This is 25, because they just told me there. So here gets formed a straight line. That's a half a circle, so that's 180 degrees. So if I'll take 90 plus the 25, that's 115. And if I take that from 180, from this half circle that's here, that's going to be 65. So this arc is 65 degrees. These are vertical angles here, so this arc is 65 degrees. This piece that's left over is, so over here is a half circle. I can do 180 minus this 65 that's already taken up and get 115 for this piece. Now I can go back and answer all the questions because I have all these parts. This is 90, 25, 65, 115, 65. So angle BAF is this angle, which forms that arc. So the central angle and the arc are equal to each other. So angle BAF is 115 degrees. Arc BC, this part, we've already found out, is 65. And arc FCD, which is this way, F, C, and D, have to follow those letters. So arc FCD, there's a part that's 115, there's a part that's 65, and there's a part that's 25. I just take all those pieces together. So that's 205 degrees. So number 6, we're finding the length of chords. So chords are segments inside your circle. They go from one the circle to the other. This seems to be displaying that this 7 and this 7 is showing that these two chords are the same distance away from the center of the circle. So if those are the same distance away from the center of the circle, then these chords should be equal. So x should be equal to 13. For part B, I need to find x. I need to find this radius. It seems to be saying this length is 8 and this length is 3. Well, this chord that's 8, it's being met by this kind of radius that gets stopped there at 90 degrees. And so what happens when it gets met at 90 degrees like that, it cuts the chord in half. So that part is 4. And 4. This x is a radius, so I can just redraw it over here. This is the same length. So now I just have a right triangle. So anytime you have a chord problem, usually they're setting you up to do Pythagorean theorem with right triangles. Okay? So they said this part was 3. We said that this part was 4 because that was half of 8. And we moved the x over here to be a radius to form a right triangle. So we can use a squared plus b squared equals c squared. In this case, 3 squared plus 4 squared equals x squared. So 9 plus 16 equals x squared. 25 equals x squared. And the radius in this case is 5. On 7, we're going to be talking about inscribed angles, angles on the inside of your circle. So there's an arc there at 110. Here's an inscribed angle here, an angle that landed right on the edge of the circle. So to go from the arc to the angle, x is just 110. It's half of 110. So in our case, x is 55. In number 8, they tell me this arc is 80 degrees. So in this triangle, this line goes through the center of the circle. That's what the C and the dot means. So this arc should be half a circle, in our case, 180 degrees. And this arc, well, this already uses up, this is also 180 in here. This uses up 80, so this arc only has 100 degrees left over. The angle across from the 80-degree arc x, so to get from the arc to the angle, we'll take half of 80 degrees. So that's 40 degrees. To get y, which is across from, that forms this arc here of 100, y should be half of 100 degrees, which is 50 degrees. And z is across from the semicircle, so half the circle. It's 180 degrees, I need to take half of that, which gives me 90 degrees. For AB, I need to find this arc. So to find that arc, I need to know what this angle is here. They tell me that these sides are equal, making it an equilateral triangle. In equilateral triangles, all the angles are equal as well. And the only way for all these angles to be equal is for this angle to be 60 degrees, that one to be 60 degrees, and that one to be 60 degrees. To go from the angle to the arc is going to be bigger. So I'm going to take the 60 degrees, instead of taking half of it, I'm going to double it to get 120. Okay, since the arc is bigger, it doesn't make any sense for the arc to be 30 degrees, half of 60. So we're going to double it. So for number 9, we're supposed to find the angle measures for x and y. So, if you have a quadrilateral four-sided shape inside a circle like this, the opposite angles are supplementary. That means the opposite angles add up to 180. So x plus 86 should equal 180. So therefore x has to equal 94. Y plus 100 should be equal to 180. Those are opposite angles. So therefore y has to be equal to 80. It says that the arc between the 86 and the 100 is 90 degrees, if that's 90. What's the measure of the bottom arc? So this arc on the bottom. Well, notice how that angle y we solved for was 80 degrees. That means this arc total should be twice of 80, which is 160. And since this already used up 90 of the 160, that would leave this bottom arc to be 70. 70 and 90 will make 160. So number 10 lists the equations for these angle positions inside and outside the circle. So if you have angles that meet inside the circle, what you do is you take these two arcs, x and y, you're going to add them, and then take half, and that'll get you your answer in there for inside the circle. If your arcs were to meet outside the circle, like in this case, here are your two arcs, x and y. If you're looking for this angle in here, I have to do x minus y and then take half of it. Okay, so number 11, it definitely looks like this situation where we have the arcs on the outside that we should add up and should equal the angle on the inside. So I need to add the arcs. In this case, that arc is x, and that arc is 86. I need to take half of that, taking those two arcs, adding them together, and doing half should equal that angle on the inside. That should equal 88. To solve for this, I want to get rid of that 1/2 because I don't like the 1/2 being out there, so I'm going to multiply this side by 2 and this side by 2. When you multiply the left side by 2, that cancels out, and I have just x plus 86 left. 88 times 2 is 176. If I subtract 86 from both sides, I'll get that x is equal to 90 degrees. So number 12 definitely looks like this situation, where I need to take the two arcs, subtract them, and that will take half of it. So here's the two arcs, x minus 20. Take half of it, that should equal the angle. The angle in this case is 35. So again, I'm solving this. I want to get rid of the 1/2 by multiplying both sides by 2. That leaves me with x minus 20. It gives me 70 here. Adding 20, I get that x is equal to 90 degrees. So in 13, I'm supposed to list the equations for the segment lengths of what can happen when the angles positions inside the circle and outside. So if angles meet inside the circle like this, like they're made of chords, this is A and B, this is C and D. So the equation is just you take A times B, that should equal C times D. If you have a situation where they meet all of it outside, like this, and this is A, B, C, and D, what happens is you have to take the outside part, A, multiply it by the whole length of the line from this edge of the circle to where they meet. So I need this whole length, A plus B. That should equal this whole outside part plus the whole line part, or times the whole line part, C plus D. And the last situation is where if you have a secant line meeting up with a tangent line. So if this is A and this is B and this is C, again, to handle this secant line, we take the outside times the whole line. That should equal this outside part, C, times the whole line, which is also C again, so C times C, or C squared. So in 14, it looks like the inside looks like this situation. So we just need to take the parts of the chords and multiply them together. 8 times 2.5, that should equal 2 times x. 8 times 2.5 is 20, equals 2x. So x is going to equal to 10. So the next situation, again, I'm going to take the outside times the whole line. So the outside part for this line, this secant line, is 5. The whole line is 5 plus 10, makes 15. That should equal the outside part here, 4, times the whole line. The whole line here is 4 plus x, or x plus 4, whichever way you want to write that. Solving this, 5 times 15 is 75. Distributing here, this is 4x plus 16. Subtracting 16, I get 59 equals 4x. And dividing by 4, x is going to be 14.75. And this one over here, again, we're going to use outside times whole line. 2 is the outside part in the secant line. The whole line is 2 plus 9, so 11. That should equal this outside part of y, and that whole line part of the tangent to be y again, so y times y is y squared. So this is 22 equals y squared. Square root both sides, and y is approximately 4.7. Okay, so 16, B and C, just kind of like really tricky things to do with the inscribed circle and central angle and all that stuff. Okay, so let's start with this. This arc here is 240. That's a lot of the circle. A circle is 360 degrees. So if I take 360 and subtract 240, that's the leftover part. So that's 120 here. So that's 120, that arc. X is the central angle. Central angles are equal to the arcs they form. So X is 120. For Y, you guys notice these are tangent lines. And tangent lines form 90-degree angles. So I'm going to redraw that picture there. These are 90-degree angles. This we just found out was 120 degrees. And so for Y, we can do 90 plus 90 plus 120. That equals 360. And to get Y, sorry, that equals 300, my fault. To get Y, we subtract that from 360. So Y is 60 degrees. It's also half of that arc that got formed. And for angle Z, this angle that got formed is 120, or sorry, this arc that got formed, Z would have to be half of that because that's an inscribed angle. Half of the 120 is also 60. (16C), there's a lot of craziness going on with this. So in order to solve for X, and Y, I'm eventually going to need the measure of these arcs. Okay. So to get the measure of those arcs, let's talk about this outside one. This gets formed by this angle, this inscribed angle in here. That's 34. I can just double 34, and that gives me the arc over here, 68. Same reasoning here. This angle is 18. This arc is twice that. So 2 times 18 is 36. So once we have those arcs, we can say, okay, this is inside for Y. To get that angle Y inside the circle, I take the two arcs, 68 and 36, and I'm going to add them, and then take half of it. So 68 plus 36 is 104. Half of 104 is 52. To get X, since that's outside the circle, I take the 68 and the 36 and I subtract them, and then taking half of that. 68 minus 36 is 32. Half of 32 is 16. The rest of the study guide, or the review, is about circles, so it should be not so bad. Or graphing circles and such. Okay, so 17a, we're supposed to identify the center and the radius, and then graph the circle. So this is written in the standard form of a circle. So remember that the standard form is x minus h squared, y minus k squared, and equals r squared, where h and k is your center, your radius, and r is your radius. So to get h and k from here, so it's like x minus -3, so the opposite sign here. So the center would be -3, -5. And just you take the opposite signs of what's there. And to get the radius, you take the square root of the number over there. So the square root of 25 is 5. There's the center and the radius. And we use that to make our circle. -3, -5 is right here. So to graph that, we go 5 in all directions. So 5 up, 5 to the right, 5 down, 5 to the left. And then we make our circle. (17B), kind of same thing. Your center is at -1, 1. Let's take the opposite signs there. And your radius is the square root of 36, which is just 6. So I go to -1, 1, and then go 6 in all directions. So I go 6 up, 6 to the right, 6 down, 6 to the left. And I'll make my circle. So for 18, I have to write an equation, a circle with these given points. So normally the equation of a circle is x minus h squared plus y minus k squared equals r squared. They give me the h and k. In this case, the center is at 0, 0. What they don't give me is the radius. So what I can do is I can take the extra point that I'm given and plug that in for x and y, because 3 is an x and 4 is a y. That should satisfy this equation. And I go ahead and plug it in, and that can give me the radius. 3 minus 0 is 3. This is 9 plus 16. So r squared is 25, and r is 5. Still have to write the equation over. I have to write x minus 0, which is actually the same thing as just x squared. Y minus 0, which is the same thing as y. And then squared equals r squared. R is 5, r squared is 25. For 18, same thing. I want to start off by writing what I know. So I would start with x minus 5 squared, y minus 9 squared, because that's the center, that's my h and k. What I don't know is my r squared. To calculate that, I use the other point that's on the line, 2, 9. So 2 minus 5 squared, 9 minus 9 squared. 2 minus 5 is negative 3. So negative 3 squared is 9, 0 squared is 0, so r squared is 9, and r is 3. But I don't just want the radius, I want the actual equation, so I need to plug this back into here. So my final answer is x minus 5, squared, y minus 9 squared equals r squared, which is 9. Number 19 is asking us to write the equation of the circle with a given center and a given radius. So start with x minus h, or 3, squared, y minus k, or y minus 11 squared equals the radius squared. So 2 squared, which gives me 4. (19b), same deal. I have to write x minus h, which is 6 squared, plus y minus negative 6. Minus negative 6 is going to change this to a plus 6 squared. And I need to take the square root of 7 squared, which is just 7 back. And lastly, number 20, I'm supposed to write an equation of the circle from the picture. So the center is here. That point is 0, 3. I can count to get the radius. 1, 2, 3, 4 units. And from there I can write the equation. I can start off with x minus 0 squared, y minus 3 squared, and the radius squared. 4 squared is 16. And I can leave it as x squared plus y minus 3 squared equals 16, since x minus 0 is just.